All right, so I think we'll get things kicked off here. My name is Don Weinkauf. I'm the Dean of Engineering here at the University of St. Thomas. I want to thank everyone for joining us here tonight. We have some great panelists who are going to be participating in the webinar and are available to answer all of your questions. I'll introduce them in a moment. But again, thank you for joining us today, especially and in these times. I know that there are difficult times for many of us and uncertain times for most of us. But also, I hope that they're hope-filled. And really, that's what I think tonight is about. It's about exploring what's going to happen this fall and the exciting things are going to be available, the exciting opportunities that are available at the School of Engineering at the University of St. Thomas. So again, thank you for joining us. So I also just want to remind everyone that there is a Q&A folder at the bottom of the webinar page here. Please feel free to start plugging in questions. What I'm going to do tonight is, after introducing our panelists, I'm just going to give you a sort of a brief overview of the School of Engineering, and then we're going to turn it over to your questions and answers, and hopefully we'll get to those as soon as possible. And so use the Q&A feature, and we will start answering your questions as quickly as possible and as thoroughly as possible. And let me just start off by turning it over to Dr. Brittany Nelson-Cheeseman. She's a faculty member on our mechanical engineering program, and just let her introduce herself.
Okay, hi everybody. I'm Dr. Brittany Nelson-Cheeseman. I'm in mechanical engineering. I also lead up our material science and engineering program. And I'd love to talk with you guys. Some of the specific areas that I'm really interested in chatting about, if you're interested, is the living learning communities, study abroad, and also student research. So great. So Dr. Kerner, do you want to take it away next?
Sure, and welcome everyone. My name is Lucas Kerner. I'm a professor in electrical and computer engineering. I teach from first years digital logic up to seniors doing antennas and other things like that. And I have an interesting research program working with cameras and other types of sensors that some of the undergrads have really excelled in. And Dr. Welt from Civil, would you like to go next?
All right, thanks, Lucas. My name is Travis Welt. This is my end of my third year here at St. Thomas in the civil engineering program. We started back in 2017 as a new program. Prior to coming to St. Thomas, I worked at the Shell Oil Company designing their offshore floating platforms as a structural engineer. And so now I'm here at St. Thomas teaching. I teach steel and concrete design, soil mechanics, and also statics and freshman level introductory course as well. I'm also doing some research that's looking at performance of automated weld systems and 3D printing of welds. So that's it for me.
And now the most important panelist for all of us, I want to turn it over to one of our students who I'm sure is going to be fielding the majority of the questions tonight, Erin Westman. Erin, you want to introduce yourself?
Thank you, Dr. Weinkauf. Hi, my name is Erin Westman. I'm a sophomore studying mechanical engineering here at the University of St. Thomas. In my just short year and a half here or so, I've had the opportunity to work in our tool crib, which is a tool library that offers material, resources, and supplies to our engineering students. I've spent a summer working in the labs, greatly improved my metalworking and woodworking fabrication skills, and I'm hoping to conduct research with one of our mechanical engineering professors this summer. I'm from Shoreview, which is a suburb just outside of St. Paul, so local to the area, and I've loved my time here so far. So thank you for having me.
Excellent. Thanks, Erin. Thanks, team. So as I said, what I'm going to do is keep plugging in your Q&A questions through the Q&A. We'll get to those. Many of the questions I think will be answered in this sort of general overview that I'm going to provide now. And maybe the team could start looking at some of the questions and coming up with some of their answers while I give this overview. So here we go. A little bit about St. Thomas Engineering. First of all, we're a Best Colleges U.S. News and World Report, have been for actually now the last 6 years. We're located in Minneapolis, St. Paul, as most of you know. Many of you have visited campus, but some of you have not. It's a beautiful setting right on really the gorge edge of the Mississippi River, right in the heart of the Twin Cities. I want to tell you a little bit about the size of the School of Engineering. Some people ask that question. Actually, today, 1 in 9 undergraduate students at the University of St. Thomas studies engineering. So you're not going to be alone. All of your classes are going to have at least a few engineers in them where you can share and chat and basically and share your experiences. And also we have enough students that there's living learning communities, which Dr. Nelson Cheeseman could also talk about, which are specifically for engineering. We have 4 accredited engineering majors. Some of the questions have asked about the accreditation of the civil engineering program. We're expecting that approval, official approval in August, but we have computer engineering, electrical engineering, mechanical engineering, and civil engineering. All of these programs are accredited by ABET, and that is the same accreditation as the Iowa States of the world and University of Minnesota, etc. So many of you are wondering, so why St. Thomas? Well, first of all, number one, we believe that being an effective engineer takes far more than just science, math, and technical skills. Engineering, believe it or not, is a people business. It's about people, and an understanding of people is critically important. Communicating with people is critically important. Will all make you much better engineers. Another aspect of engineering at St. Thomas is our industry connection. We're very industry facing. The industry is a big part of what we do in terms of internships and jobs, as well as projects that our students can get involved in. And the reason why they can get involved in it is they have a tremendous amount of hands-on experience. Erin referred to that in her introduction, is the metal shop and the machine shop and Arduinos, and whether it doesn't matter what major you're in, you're going to get your hands on things and you're going to get your hands dirty, and that's a part of learning. We have an engaged faculty with incredible range of industry experience, as Travis, Dr. Welt was referring to, our small class sizes, which all make a really unique combination and a powerful combination for creating great engineers and an engineering experience which is very different. We have, as I said, very hands-on practical education. This is our examples from our senior design clinic where students work directly with companies in their senior year, whether it's small company, medical device companies, or large companies like 3M. Actually, the picture in the center of the slide here is actually a project that we've done with 3M on creating a new type of television that runs purely on the power of an Ethernet cable. As I said, we have engaged faculty with real-world experience. It's a picture of Dr. Tom Secord, who has his PhD from MIT and has 5 years of experience at Medtronic. But the list of panelists that you have here before you have Dr. Welt, as he said, he worked for Shell Oil Company designing oil rigs. Dr. Kerner worked for Apple, designing cameras for your Apple iPhones, and Dr. Brittany Nelson Cheeseman, who worked at Argonne National Labs before joining us here at St. Thomas. Again, that real world experience, the faculty have it and they inject it into the classroom. Now, something else that's unique about St. Thomas too is we don't have any PhD programs here, which means the research that our faculty do is really largely done by our undergraduate students. And the amount of time that our faculty spend, would have spent advising PhD students is time that they're spending with you and your development at the undergraduate level. And as I said, because there is no PhD program, a lot of our students get involved with the research that our faculty are engaged in. About 40% of our graduates have conducted research with faculty outside of the classroom. And all of the faculty panelists here, and Erin, a student representative on this panel, can tell you a little bit more about that. A lot of people don't equate engineering with study abroad, but as Dr. Nelson Cheeseman indicated, it's a big part of what we do. We have senior design clinics, we have semesters abroad, we have J-term, which are all great opportunities to study abroad. In fact, we have one of the highest percentages of engineering studying abroad in the country. About 45% have studied abroad before they graduate. And then, of course, we're here in the Twin Cities where there are tons of internships and jobs. In fact, we do a reverse career fair in the fall, every fall. Last fall, we had more than 90 companies represented, sending 180 company representatives to interview 200 of our engineering seniors and students seeking internships. So it was almost like this wild speed dating session that we had here in our big alumni hall with 180 company representatives coming to interview our students. And this is where our students work. Every part of this Twin Cities region and across the country, great opportunities, things like Target and 3M and Honeywell and Ecolab, all big parts of the employment base that support our students, not only with full-time employment, but with jobs, with internships, and then of course, projects that get injected into our senior design clinic. And finally, you know, it's really important to communicate that, you know, all of this education needs to be translated into things that make a difference. Whether you're working at 3M or you're working at a small company, products and improvements that you make to those devices all improve the life of the people around you. And here's one great example. This is our students working right now with their hands-on skills, machining injection molds for face masks to be distributed here in the Twin Cities region. So with this advancement of using their hands-on skills to create this mold, we're going to be able to produce hundreds of face masks per day. And with that, I would just like to turn it over maybe to Erin, our student rep, who's part of this team that's been working and now will be working very much so on the manufacturing of face shields for the medical community here in the Twin Cities. So Erin, you want to take over from there?
Absolutely. Thank you, Dr. Weinkoff. Yeah, so when classes were converted to an online format, my peers and I realized, you know, just because we're no longer on campus together doesn't mean that we can't make a difference in our community. We can't do something to aid those that are on the front lines of battling this pandemic. So we reached out to a number of local healthcare professionals to ask them, what can we do to help? You know, we have these industry grade manufacturing tools and processes that are at our fingertips, just waiting to be utilized. And we have the experience, we have the knowledge and the skills to put them into use. So we contacted local hospitals and clinics and determined that one of their greatest needs was that of plastic face shields. They didn't have enough PPE, personal protective equipment, for their staff. So we began 3D printing some of those face shields. We originally were outputting about 30 a day on our 3D printers that we had here on campus. And after our university's newsroom published an article about the work that we were doing, we had a couple professionals in the engineering industry reach out to us on LinkedIn that wanted to offer up their injection molding machines. And so we created a mold for the face shield headbands that we had been previously printing. So what was an output of about 30 shields a day turned into now several hundred a day being injection molded. So we're currently partnered with Hennepin County Medical Center and Children's Hospitals of Minnesota. We've also worked with a few smaller partners like the U of M Dental School and some local senior living care facilities. So we've been donating to all of them. We've donated several hundred shields so far, and we have, you know, no intention of stopping. So this is just the beginning.
Great. Well, thanks, Erin. So, and also thank you for all of your questions that are streaming in. Maybe it might be good to start with this one. Since engineering is such a male-dominated field, how is it managed? How do you manage that with women who would like to join? And maybe let me turn that over to maybe Dr. Nelson Cheeseman to talk about what we're doing in terms of women representation in our programs. And maybe Erin also might have some opinions about that in terms of what her classroom experience is like in such a male-dominated profession, and it is. Brittany?
Yeah, great. So, first of all, I will say that it has been pretty exciting at the University of St. Thomas over the past couple of years. We are seeing our female engineering student numbers tick up slightly. So that is definitely a promising sign. I also too want to highlight that almost 50% of our faculty in mechanical engineering is actually female. So that just creates a really awesome environment. I think it's very important that, it's not just for our female engineering students, it's for all of our engineering students to see that representation on both sides of, the gender scale. And so also, and perhaps Erin, I'm not sure if you're involved in this or not, but we have a really amazing, thriving Society of Women Engineers chapter that is, I was the advisor for a few years ago. And they do an amazing number of things. They do social events, they do study hours together, they bring in people from industry, female engineers from industry to talk about what they're doing in industry. They do grad school panels. They just have a great community, and it's not, just females, but it definitely is a place where the females are the majority. And so it's kind of a cool flipping of the scales, if you will. So Erin, do you want to maybe share more things about from your side, from the student perspective?
Absolutely, absolutely. As a female engineer, obviously, like you said, it is a male-dominated profession and a male-dominated major. However, I've never felt uncomfortable here. I felt very well supported by my peers, male and female alike, and by my faculty, male and female alike. And as Dr. Nelson-Cheesman was saying, we do have the Society of Women Engineers. It's actually, I was just voted networking chair for the 2020-21 school year. So I am very involved, and that group of girls and guys has been they've provided a wonderful space for us female engineering students and male too. They do participate to connect with each other, across the different engineering disciplines. And like you said, we have a variety of different events, both social and educational, networking. And that space has been one where I've found some of my closest friends and made better connections with people that, I wouldn't have had the opportunity to otherwise.
And I don't know, Erin, if you have been able to participate in this yet, perhaps because it was in Minneapolis recently, but there's also the national conference every year for Society of Women Engineers. And we always send a contingent of engineering students, I think sometimes even a few guys, to the National Society of Women Engineers conference, where a lot of our students then are having interviews at that conference and just learning a lot of leadership skills and networking. And I've just heard fantastic stories from them about that.
Yes, I have not attended myself, but I will be attending next fall at the conference in New Orleans.
Excellent, excellent. All right, there's a few more questions rolling in. There's opportunities for double majors. But I tell you what, there's a couple that I think I can click off real quick here. There's several questions about what kinds of computers that the student should have. And we have some very specific recommendations that we could send to you, but maybe Lucas and Travis might want to comment about the computer needs of a student in the classrooms when they're coming in as freshmen. Travis?
Yes, sorry, I was writing a response during the question. Well, I know that we have our standard specification from the civil engineering side of things. Most programs that we use, well, it's getting better now, but many programs are limited to Windows as opposed to the Mac OS. But you can, if you are set on a Mac, you can, boot camp Windows on there if you need to use it. In terms of specifications for the programs we're going to run in our civil engineering department, I can't imagine you needing more than 4 gigabytes of RAM. Would be a pretty standard computer. I cannot speak to the EE and computer side. They might need more than that. But from civil, you're not going to need, a supercomputer.
Yeah. So let me just say, yeah, we have some and instead of us detailing which kind of graphics cards and everything like that, let me just say that our computer system support team has very detailed recommendations for, and it does, as Dr. Welt was indicating, it does vary a little bit by major in terms of those recommendations, but really there's a very clear response, and we can easily send that out to you if you want to detail it. But yeah, in terms of those exact details of which cards and which levels of RAM and memory, we'll send that out to you. What about the question, again, here's a question about what about the job markets for your majors? And maybe we could just rotate that around in terms of, there was a specific question about a job market for civil engineers, and maybe we could talk a little bit about that, Dr. Welt, or what we're hearing from companies in terms of demand for our students. Maybe we could even reflect on the reverse engineering fair, a reverse career fair, in terms of the response from companies with our students.
Sure. Yeah, I also just posted a response to that one. It's a little wordy, so I could just describe it here. I think one of the main purposes of developing a civil engineering program here was the significant demand of civil engineers in this area and all over the country. As you probably noticed, there's the infrastructure in this country is has taken a hit. It's a little old and it needs to be replaced. And there are not enough civil engineers by far at this time to fix it. And so the market for civil engineering is very strong right now. I mentioned in my answer that 100% of our first graduating class was placed. There was 3 people in our first graduating class. So I know I can skew the statistics very easily that way. One of them went to grad school at the University of Minnesota in our architecture program, and the other 2 are working at civil engineering firms, both in the transportation field. But if you look at our student body currently, all of our seniors have had internships. I believe all of them have jobs lined up for the summer, and the majority of both our juniors and sophomores have had internship experience already. The companies are not sure the best word to use for it, but they're pining for engineers. There's just not enough civil engineers in the world right now. So in the country of the world. So.
Lucas,
Well,
you want to talk a little bit?
Well, I just want to say my brother-in-law is pretty high up at a local civil engineering firm, and when he found out that St. Thomas was adding civil engineering, he was basically drooling, saying, "Oh my God, get me some of your students. We need your students." So really, I think the job placement is just going to be phenomenal. So.
Lucas, what about double E's?
Yeah, and I'd say the seniors I teach for electrical engineering, especially last year, all of them were placed with a couple months left in the semester. A lot go into the energy field, so say Excel, but then there's also some who do embedded systems, so programming, and they had positions there. And I just heard back from one who was accepted to a PhD program at Biomedical to do some medical imaging and things. So there's lots of job opportunities that go really well, that are great for our students, especially in electrical.
Yeah, so let me, there's also some questions streaming in about double majors and minors, and there's a lot to explain there. There was also a question about access to biomedical tracks. And maybe, Brittany, maybe you might want to comment about that a little bit. But we don't have that degree specifically, but it's sort of a false cognate because we're surrounded by companies that are very involved with medical device. And certainly our electrical, computer, and mechanical engineers are being placed into those companies. So Brittany, maybe you want to expand on that a little bit?
Yeah, I mean, so this is a really, really common question that we get, concern that we get from prospective students and parents. And we work pretty closely with a lot of the biomedical companies around the Twin Cities doing our senior design projects. Many of us are doing research projects with them, outside of coursework and things. And what they tell us again and again and again is basically, we would so much rather have somebody who had a strong foundation in engineering, mechanical, electrical are the 2 main ones for the biomedical devices, and that we can teach them the biology aspects and kind of the finer tuned aspects. They really want that problem solving and that kind of just mental approach to how to solve problems that you learn and it's honed in an engineering major. And so having the specific biomedical engineering itself is actually kind of like a piecemeal of like a little bit of mechanical, a little bit of electrical, a little bit of materials, a little bit of biology. And so it doesn't really give you as much of a strong foundation in something. Whereas if you're working at a biomedical company, they can create a team of a mechanical engineer, an electrical engineer, a material scientist, these people that then can come together and bring their depth. And so really, they tell us again and again and again, we want your mechanicals, your electricals, your computer engineers to be able to, work on these aspects that, that they're going to be working on with the biomedical devices. I will say that the mechanical faculty and the electrical and computer faculty have started exploring the possibility of creating a biomedical engineering minor. So that would be able to kind of expand some of those exposure, if you will, to have a little bit more physiology and biology aspects. So that is something potentially coming down the pipeline that could be an option.
Great. And speaking of minors, so there's some questions pouring in about double majors and minors that maybe we should address. And maybe Erin's considered this in her track as well. But there are a large number of minors and there are a large number of double major possibilities. And what I want to convey to you is that really each one of those decisions that a student makes in terms of minoring in this discipline or double majoring in this discipline, it's really part of a conversation that we want to have with the students in terms of what are they trying to get from that? Because there's a lot of misconceptions about double majors and minors and what it will do for someone in the market. For example, you know, if you double major in something like physics or mathematics, when you have an engineering background already, it's sort of assumed that you're pretty strong in physics and mathematics. So what we would want to do is all the people on this panel, and maybe Aaron can even, the whole point of having this connectivity to our advisors and the faculty is go through that, go through the value, because if you're staying at the University of St. Thomas for an extra semester to get a minor or an extra year to get a double major, we'd want to have that conversation with you because a year out in industry may be more valuable to you in your career and what you want to accomplish with your career than sticking around St. Thomas for that double major. Not discouraging it, but it certainly is something that good advising will lead to in terms of you know what is the best track for you. And speaking of advising, Aaron, do you want to just talk a little bit about your experience with your advisors and what that's like for students out there in terms of, it seems like there's a lot to navigate, especially your freshman year, and just maybe explain a little bit about what your experience was with you know, working with your advisors in the School of Engineering and how those conversations go.
Sure. So my advisor is Dr. John Wentz. He's the chair of mechanical engineering here at St. Thomas. And I met him during welcome week of my freshman year. We had our first conversation. We sat down and just talked about my intentions, my plans for my engineering degree here at St. Thomas. And since then, I've met with him on a fairly regular basis. Certainly every semester for our mandatory advisor meetings. But his door is always open to me. He's always just an email or a phone call away. And he's available to answer any questions that I may have regarding my major, any minors that I wish to pursue, classes that I'd like to take in the order in which I'd like to take them. But also outside of that, you know, he's available to answer questions about choices that I make now as an undergraduate and how they will affect, you know, my career path after I graduate, or whether or not I want to pursue grad school and what that may require from me now. So I found him to be extremely accessible. That, and, you know, not just my advisors, but my faculty too. We have casual conversations after class about, you know, my interests and what opportunities I could take advantage of now as an undergraduate to prepare myself for a successful career as an engineer. And I want to say that that's ever changing too. You know, when I first arrived at St. Thomas, I intended to double major in French because I had attended a French immersion elementary school, and I've since decided not to do so. I did take some French classes, but my interests, you know, have changed, and now I'm interested in pursuing, you know, undergraduate research and robotics and mechatronics. And so, you know, I've decided to allocate a little more time to that. So it's ever changing, and these advisors and these faculty members are available to, you know, help you make those decisions every step of the way.
That's great. I think that's one of the most difficult things as an engineering college student is that there are so many opportunities and you have to choose. I mean, college experience like that at the University of St. Thomas provides you 2 lifetimes of experience that if you were to try and do it all, but you only have a few years here and you have to make your choices. And I think that's why great advising makes a huge difference in terms of which internship do I take, in terms of should I think about graduate school. All that stuff are part of those conversations. And what's great is your students are going to know these faculty members, and they're and as Aaron said, the doors are always open, and that's a requirement here in the School of Engineering that our faculty are available, because our faculty are here for you. I mean, our primary mission is the development of our students and the transformational educational experience that we're trying to build here. There's been a couple questions about graduate school, and maybe Brittany and Lucas and Travis, you might want to just maybe start with Brittany in terms of maybe her experience with advising students to go on to graduate school and maybe what opportunities would be available. I mean, at the baseline, what kinds of graduate schools can you go to once you've attended engineering at the University of St. Thomas?
Great. Yeah, I think I think student research and being a mentor to my undergraduate researching students, I think is one of my favorite parts of my job. And it's just amazing to see the students progress through multiple semesters, multiple years. It's just really exciting to see that progression. And because of that experience that they have, they then, a lot of them, they are giving presentations at local seminar, local presentations, poster presentations. They're going to national conferences and they're giving national conference presentations. Some of them are writing journal article papers and having publications by the time they graduate undergrad, which is pretty unheard of. So I've had a number of students go on to graduate school. I have a student who is going to be starting his doctorate at UC Berkeley in the fall. I have another student who's going to be doing a master's at Georgia Tech in the fall. So there's a number of students that because of this really close connection that we're able to have with them with research, they really are a part of the process and they're guiding the process. They're really part of it. They're not just kind of tacked on with a bunch of graduate students. And so because of that, they really understand the research process and they are really attractive then to graduate schools when they apply.
Great, great. Lucas or Travis, do you have any other additions to that?
Sure. So a student I worked with over the summer, also a ROTC cadet, we published a paper in IEEE sensors on measuring depth with small little instruments. And now he's going to get to go on to graduate school. So that was an excellent success. Another student, an electrical engineer, was in a senior design project, was working on a scanning microscope that actually used ultrasound, and now he's going to do medical imaging at Mayo Clinic in a PhD program. And one thing I note there that a lot of you might be thinking, ooh, what about aerospace or what about biomedical? Those are often fields that you can kind of branch out into when you do a master's or a graduate program after starting with a fundamental base in, say, mechanical engineering or electrical engineering. And that's what the student who's going to Mayo Clinic is doing.
I would add from the civil side, you may think that, concrete's been around forever, so there's no new developments in it, but there are. But I think there's two different kinds of students that go to grad school out of a civil engineering program, and maybe there's more than two, but there's two that came to my head. One would be students that are interested in going into industry, specifically in the structural engineering field. There's a significant number of larger structural engineering firms that are requiring masters now, or at least looking very highly on it. But that's not necessarily going to grad school to do research for 6 years and get a PhD. That's going to a 1 year, maybe 1.5 year course only master's program where you're learning, just the next level of everything, steel, concrete, wood, all that kind of stuff. Whereas, the other student may be more interested in doing, real, laboratory research, either experimental or analytical. And that's another route you can take. So I think a lot of that has to do with, the conversations you have with your advisor and your peers.
Yeah, and I will say that in terms of research, I know there's many of you are probably thinking about the schools with PhD programs and those research, the word research, how often it gets mentioned when you're talking to those schools. But I will say from personal experience that there are probably more opportunities to do research as an undergraduate student here at the University of St. Thomas than there would be at those institutions that tout themselves for their research enterprise. And that's because the students at those schools are typically PhD students and not the undergraduate students. So in general, there are probably far more far more research opportunities for students at the University of St. Thomas at the undergraduate level than there would be at most other institutions. And those research opportunities are all things that you can put on your resume that would be attractive to these graduate schools like Berkeley and like Georgia Tech or wherever you want to go. And that way you can really parlay that research experience here with understanding what it would be like to do research at these larger, more PhD-driven institutions. There are a few more questions floating in, especially around what's it going to look like this fall with social distancing. And I think that that's going to be a big conversation. But maybe what I would like to do before we get to what the fall is going to look like, there's lots of questions coming in about what kinds of student clubs are there, what kinds of activities you would do. Well, someone even asked, what would be a typical week, for a first year freshman? Can you get involved with clubs? Aaron, do you want to just chat a little bit about what's it like for whether it's the robotics club or the rocket club, or you mentioned SWE already in terms of Society of Women Engineers? Maybe just talk a little bit about the clubs. And I think even more interesting is how it doesn't matter what club you're in. Like, for example, your face shield manufacturing team is really an organic development from students from multiple different clubs. So maybe just talk a little bit about clubs, and maybe Travis and Lucas and Brittany can chime in as well. But Aaron, you want to just talk a little bit about club activities outside of the classroom?
Sure, absolutely. So like I mentioned, for the upcoming school year, I'll be serving on the executive board of the Society of Women Engineers as the networking chair. However, I'm also involved in the Engineers for a Sustainable World Club, which focuses on engineering with the lens of sustainability and environmental responsibility. So a lot of these clubs, we have what's called conversation hour here at St. Thomas every Tuesday and Thursday afternoon. It's about a 2-hour window where no classes are held, and that's when most clubs choose to meet. So we have weekly meetings. There's the American Society of Mechanical Engineers, IEEE for electrical engineers, American Society of Civil Engineers. So there are clubs within the School of Engineering that are focused specifically on your discipline, but then there are also ones like SWE and ESW that are a little more universal and bring, both female and male students together from all different disciplines. And like I said before, all these clubs host social events, just to connect and meet outside of the classroom. They also host educational seminars and opportunities to network either with alumni from St. Thomas or industry professionals will come in and share their experiences and their advice. And there's always free food, which is a great reason to come. And keep in mind too, there's a wealth of other opportunities to get involved on campus outside of the School of Engineering. I'm going to be president of the Rock Climbing Club next semester, and that's a group where, although there are many engineering students involved, I've met students from all of their majors. So, your freshman year social life, there's lots of different opportunities. We have the club fair every fall where you can, meet with representatives from all of the clubs and student organizations on campus and get to know them a little better, maybe find some new interests and new hobbies. And you're going to have so many different social opportunities amongst, those that are available to you inside the classroom as well.
So there was a question. Any other input on the club activities from our panelists?
I don't know if now is the right time, but I think definitely like the LLC might be something to bring in there, but we can come back to that too. There have been a bunch of questions about that, but.
Yeah, so I'll tell you my own experience with student clubs is really what I see it is groups of students getting together, coming up with great ideas, coming up with activities, whether it's visiting a company or having someone from a company come here, or attending a conference where you're meeting with like-minded people from across the country, across the nation. We have a rocket club, a robotics club, and again, all of those details. If anyone has a specific question about one of those clubs, we will get you to that faculty advisor, and they could or the student president of that club, and they could describe their activities for the year. So for example, I believe that if we were running as normal this spring, we would have launched a rocket in the desert of New Mexico, through our rocket club. And they would have been launching it into outer space, believe it or not. And engineering students at St. Thomas do that kind of stuff. So it's just exciting to see the excitement in the students when they walk into my office with great ideas of which to pursue, whether it's Rocket Club or Civil Engineering Club or the Society of Women Engineers. That's my job and on all the faculty's job is to support those great ideas and activities of our students, because that really adds another dimension to your experience here at St. Thomas. There's a question in here from the electrical engineering faculty. Is what's the connection between electrical engineering and music? And I can answer that too if you like.
Yeah, I've messaged a little bit.
Throw you a curveball, Lucas.
I messaged a little bit with Zach Gold there, and I do there's a student in my senior class, an electrical engineering major, and I think he's also double majoring in music. So I'm gonna check in with John and see how that's going, and I'll send Zach some info based on that.
And there's
But
lots.
Don, if you know anything else, feel free.
Yeah. Well, there's lots. I think every one of the engineering disciplines really interfaces with acoustics and music. We have lots of students who double major. Aaron might even know some students. Many students use their choral experience or their orchestra experience as their fine arts elective. So there's lots of opportunities to interface both engineering and music. We even have a research group that's working on something called Codes and Chords, which is translating music using computer software into visuals that people who suffer, who are deaf, can actually see music versus hearing it. We have one of our mechanical engineering faculty who's doing acoustic work on the impact of acoustic waves on rocket engine propulsion efficiency. We have another mechanical engineering faculty who's looking at how can we convert sound energy, sound waves into actually electricity. So there are lots of different intersections between, I would say, music, acoustics, and engineering, and then the art of music, which are all possible through St. Thomas. Like I said, many of our students participate in choral, the chorus, many of our students participate in the orchestra, and again, they use that experience really to meet their fine arts requirement, and again, have a whole other dimension to their student group and activity intersections that would happen through whether it's through sports or through the music program. So there's lots of opportunities for engineers in music. Aaron, do you know any colleagues that are right now at that intersection? I'm taking a chance there.
I do know many of my peers for their fine arts credit are taking advantage of that opportunity to participate in one of the music ensembles here at St. Thomas, whether that be choir, orchestra, and I actually myself, my freshman year, played in the guitar ensemble for a semester. So those opportunities are definitely available to you if you would like to seek them out.
Great. And I think that's just testimony, again, the abundance of opportunities that exist no matter what your interests are, whether it's robotics or rockets or music. You're going to find, there are 6,000 undergraduate students studying here. There are 400, nearly 500 faculty with PhDs from almost every possible corner of the planet and every discipline. And there's so many ways to satisfy your interests through those kinds of engagements. And I said, every one of those faculty, every one of those student groups is really just open to that idea of interaction and interfacing with you, because it's just going to keep growing and carrying on that way. Now, I will say that there have been a few questions about what the fall is going to look like, and I think it's important for us to take some time to talk a little bit about that, and maybe I can start, and then maybe some of the faculty can give some examples of how they're dealing with that right now. But I also will say that there are a large number of questions streaming in, and I just want to convey that every one of your questions will be answered. If we're not going to hit it here tonight during this webinar, we will make sure that no question will go unanswered. So whether it's best for me to answer it or it's best for someone like Aaron or Dr. Nelson Cheeseman or Lucas or Travis to answer that, or someone in admissions office or someone in our academic counseling department or wherever it is, we're going to get your question answered. So the questions are streaming in. We're going to try and do our best to cover all of them. Please answer more questions, because as they accumulate, that might prioritize the questions that we might address here during the webinar. So let's talk a little bit about the current circumstances with the pandemic, how we're dealing with it, and then what we might expect this fall. And I think all the panelists would be able to provide you with some great examples of how we're dealing with this. Right now, the university is going through several scenario plans in terms of what September 1 will look like. There are 4 sort of plans. One is we're as where we are today. 2, we're as where we were beginning of September in the fall of 2019. But then there are a couple of intermediate ones, and most of those involve things like social distancing. And that's where a lot of your questions are coming in, is how are we going to achieve the goals of our hands-on experience, that student engagement with social distancing. Obviously, you can understand that classrooms, if we're going to be practicing social distancing, there might be a fewer number of students in each class. Perhaps there'll be more of a hybrid model in terms of delivery if we are in that social distancing mode. In terms of laboratories, it would be the same thing. Most of our laboratories have a large number of stations, where instead of having 14 students or 12 students, we might have 6. So we're running through all of those scenarios to make sure that we're going to be able to achieve our goals of hands-on experience. But it's a moving target. It's evolving. The recommendations from the Minnesota Department of Health will heavily influence how we restart the fall. But I will say that we have a very creative group of faculty who are well honed in terms of how to deliver flipped classes and hybrid classes. And we're going to go to every effort possible to make sure that hands-on experience is going to still be a part of who we are and the experience that your students have. Because I said, we're not going to forget who we are. And those 4 or 5 things that we put up at the beginning in terms of practical knowledge, in terms of understanding people as an engineer, that breadth is required, all of that's still going to be a part of St. Thomas in a big way. And we have, again, some incredibly talented people who are going to find ways to make sure that persists. And I'll just draw on one example. Dr. Kerner is conducting an purely online electrical engineering course this summer with his grad in the master's program, and maybe just describe a little bit about that, Lucas.
Sure. So a master's class I teach is called Sensors for the Internet of Things. And we kind of combine electrical engineering and physics to really understand how temperature sensors, humidity sensors, cameras, other things like that work. Over the next week or 2, I'll be building up a kit that will be mailing to all the students in the class. It'll have a board on it with a host of sensors and a handful of other things to excite and challenge those sensors so students can collect data as we're working in class. I think one thing they'll be tasked with doing with all the sensors they have is they need to tell me if their sensor is outside in the dark and has detected a loud noise. So they're going to combine all those sensors and try to figure out where they are. So I think, and that's definitely kind of enabled by the fact that this class will have 15 or so students in it that will be delivering the hardware to them, ship it out, and they can all work with us online.
Mm-hmm. Brittany, do you have some examples of what's happening in more of a distance learning mode, which again, it won't be entirely on, we don't believe it'll be entirely online, but there will be a sort of a hybrid mode where there'll be some activities still in a flipped mode or a hybrid mode, and then other activities that will be in face-to-face in the lab, maybe in smaller groups. But Brittany, what's happening right now in terms of what you're seeing with labs in the mechanical engineering program?
Yeah, so specifically, for instance, in materials, that's one of the classes that I teach and work with. What we're doing is actually having, not just sending the students maybe data or something like that and saying, okay, analyze this data, but we're actually having, all of these cameras and actually testing the materials right in front of them while they're on Zoom to be able to have them kind of be part of the process and see the kind of, the in real time, if you will, kind of what happens during testing these materials. Also this week in lab, actually, we were bringing in via Zoom a local company that does a whole bunch of failure analysis and testing with electron microscopes and things like that. So the students got to see, get taken through the process of seeing an electron microscope work and see how that is analyzing their samples that, they then are going to get the data back on. So they're trying, we're trying to really include them in the whole process and not just kind of, okay, analyze some data that, was taken somehow. So.
Travis, I know there's some interesting things happen with the concrete samples in the materials lab. Maybe you have a, how are we managing with the distance laboratories in civil?
Well, concrete is unfortunately exceptionally boring when it fails. It just crumbles apart, unless you make it super high strength, at which point it explodes. So it depends on how much strength you have in it. But I know that Dr. Letterly, she runs the materials lab for civil engineering, and she's been recording, these failures and then discussing them in Zoom with the students, and then having them work through their reports in that similar fashion. One thing we're planning to do in the fall that we could also incorporate as a e-lab possibility would be a local geotechnical engineering firm has offered to come drill a boring on campus. Don, you didn't hear that, so you.
Yeah.
And and so then they'll be able to either watch via Zoom or whatever the situation is. And then they'll actually see where the soil is coming from and see it come out of the ground. And then, when you're analyzing that, it's a little different than just analyzing, if, Dr. Weld tells you that there's, 40% fines and 60% coarse, that's a little more exciting to see something from the actual campus where you're at. So those are some of the things we're trying to incorporate as well.
Yeah, and I will add that, again, there's lots of ways to share. We are anticipating, some sort of hybrid mode of delivery, all the way back to where we were, to some sort of hybrid mode where we have social distancing. And again, most of these labs, given our scale, would be achievable with, let's just say, 4 to 6 students in a large laboratory. Versus, again, all 12 or 14 students that we typically would have. So I do believe we would still have lots of opportunities for hands-on work. And I said, I think it's seeing the creativity that you've seen just right now represented in a small sample. You'll continue to see that. And then especially when we have a whole summer to think about what those possibilities are, there'll be more and more engagement with that level. But again, we won't forget who we are. We're going to insist that you get that hands-on experience. And maybe, Lucas, you have something else to add to that?
Just to add to that, we're still maintaining that one-on-one interaction with students and kind of the open door policy. And for me, it's the open Zoom policy, but I just have it running in the background and students can hop on whenever and ask questions on homework or anything else they have questions on.
Yeah, so you were even sharing an example of like what that could look like in this Zoom environment where, again, the faculty still are maintaining advising sessions, office hours, recitation sessions to help with homework, all done in sort of a one-on-one or a small chat room kind of environment. And I think, Lucas, you wanted to, maybe you can share your screen in terms of how what that might look like. Is that a possibility?
Sure, I can share that. I'd say we can keep going while it's playing, but this will just give you an idea of how, some of these office hours actually work pretty well in the cloud, right?
Yeah, and so I think that's the thing is getting back to that creativity. And here's Lucas's example of working with a student on a programming problem.
So this is just an example of a one-on-one session, right? Where we're looking at the same screen. I'm scribbling on it. We're talking about it. And the student kind of can come away with a better understanding of what we did in class. And I'll stop sharing that now.
Okay. Aaron, do you have any good examples of how we're continuing to maintain, advising and homework help and all of those things that we might be facing if we're in a social distancing mode this fall?
Sure. Just last week, I met with my advisor for our semester, advising meetings. We could discuss the classes that I intend to take in the fall semester. And then even today, I spoke with one of my professors to clarify some questions that I had on material, and that can be conducted, at yours and the professor's convenience. So you can find a separate time to meet as you would one-on-one in office hours. I've also just had a few quick questions answered at the end of a lecture, which had, 70 people in it originally, but the professor stuck around so I could speak with her individually, get some questions answered on lab. And it's not just your professors that are available too. We have lab assistants and teachers assistants in all of our labs. I have one in my chemistry class, chemistry for engineers, and in my mechanics and materials class, which is a mechanical engineering course. And those student assistants have made themselves available to us via Zoom and email as well. So I've spoken with my TA for my mechanics and materials course with a few questions I had about ANSYS, which is the software package that we're currently familiarizing ourselves with in that class.
So Brittany, do you have something to add as well?
Yeah, I was just gonna, it's funny, Aaron, because you said 70, I was gonna say, you know, one of the advantages of St. Thomas, especially in engineering, especially with the STEM classes, is that, you know, even if we are doing these online classes, the class sizes are much smaller. And so that really is going to help facilitate, you know, as a student, you know, it's going to lower that bar for them to speak up, to ask that question, for the faculty to be able to kind of monitor the situation and, you know, make sure students seem like they're understanding things. It's just that much easier. It's kind of funny because I was thinking of that, and then Erin said her 70-person class, and I knew exactly what class it is because we have one class like that, and it's chemistry for engineers. But all of our other classes are, you know, at most maybe 35, you know, students. And so, so that really helps to really foster that student faculty bond, which is really great.
Yes, definitely. I should have clarified that that particular lecture, General Chemistry for Engineers, is the largest one that I've ever had and ever will have here at St. Thomas. Most of my classes have ranged from, I've had as little as 13 people in one class, but I'd say typically it's around 20, 25.
And I would say that's very, very different than, you know, so somebody asked, for instance, what are some of the big differences between like the U of M or some of the big state schools? I went to a state school for my undergrad, and I would say that was pretty hard about freshman year, that I was in classes that had 300 students in them. I can't imagine doing online a 300 I don't know, you know, what they're doing about that now, but, you know, so something to think about as well in terms of, you know, that engagement aspect.
You know, in this conversation, Erin mentioned teaching assistants and students that are helping with the laboratories and as well. I mean, that's another great job opportunity for students while they're at St. Thomas. Erin, as she said, she's the manager of our tool crib, and that's a job that our students do to maintain the laboratories. Part of that as well is being a helper in the laboratories. So, you know, whether it's call it a TA or a student peer mentor, those would be students who have already taken the course, done well in it, have worked with the professor in terms of how we can improve the delivery and the connection to our students through those courses. So if you think about all of those opportunities, it's great experience. It's a great way to get to know the faculty a little better and the staff better. And so again, there's abundant number of opportunities, whether it's research, which are also paid positions, whether it's working in the laboratories as to support the labs like the tool crib or the 3D printing center, or you're actually helping with a class in terms of as an upper level student, in terms of maybe a junior or a senior who already taken that and understands the material very well and makes himself available for effectively office hours, student to student mentoring. And sometimes it may be a little more approachable in terms of the students like learning from fellow students. And I can see Erin shaking her head.
It's very true. It's very true. It's nice to be able to meet with peers that are a little bit older than you, a little bit more experienced and have taken the class before. And I should also mention too that even though we're not in the classroom together for the remainder of the semester, I'm still meeting with my peers to study for exams, you know, obviously via Zoom, or to, you know, work on homework together. So those interactions are still occurring.
Okay. So there's another subject coming up here. And again, if there are more questions about what reopening and restarting looks like, and I imagine that that's top of mind for many people, I'll just to summarize, I'll say that that's evolving. I very much trust the passion that our faculty have for delivering a high quality engineering educational experience. And that passion is going to be leading to just some really creative things on how we're working through rejoining with a social distancing sort of profile. Some other questions are sort of in aggregate are, what about study abroad? And I mentioned that, you know, a large number of our students study abroad. And I'm going to turn that over to Brittany to sort of summarize what those study abroad opportunities might be, and maybe the whole range, and then maybe we can talk about a few specific examples of just exciting things that are happening.
Yeah, I mean, it is interesting that you say summarize, because we have so many different types, even within engineering, which I think is one of the really exciting things, really. So we have, of course, you can do a semester abroad where you actually go and live abroad, you know, in a different country, take, you know, and we have actually agreements set up with, you know, various in Spain, in England, in Australia, you know, in other parts of the world where we know exactly what engineering classes you can take that will transfer back to St. Thomas so that you don't, you know, fall behind. I know that's often a concern for people. We also have this cool nifty thing called a J term, where, you know, the January term is usually students either on campus can take one class kind of condensed intensively over January, or you can go abroad for January and do one class abroad somewhere, either with a St. Thomas faculty member, or we're also part of a consortium that there's a number of different options available that you can choose from. Those can be engineering classes, those can be non-engineering classes. You know, if you want to do philosophy in Hawaii, or you want to do social entrepreneurship in India, you know, I mean, there's so many different things that you have available to you as a possibility. We also have internship possibilities. So for instance, our German and engineering double major program is really exciting for those of you guys that might be interested in German. That has guaranteed internships both in Minnesota and then also in Germany, as well as taking classes in Germany. And then lastly, one of the things well, two things. We also have summer study abroad classes. I taught 2 summers ago renewable energy study abroad in Europe, which was amazing. And then also one of the things that is really close to my heart, which I think is really amazing, is our senior design capstone class that all of our seniors take. It's a 2-semester sequence. It really is the capstone kind of crowning project that our students go through. Usually it's done on campus here during the normal, you know, fall, spring school year for most of our students with a local company. But this, we've now created 2 different pathways. One where the students go to Amman, Jordan, and they live at Amman, Jordan for the summer and do the first half of their capstone project. And then they come back in the fall and they continue that project while they're taking their other classes. And then the other one that I'm personally more involved with as the faculty advisor, the students go to Peru in the Sacred Valley near Machu Picchu, and they live in Peru for the summer with homestays. All of these are with homestays. They're living, they're really immersed in the culture, and they're working on the project in the context of the project to really get that understanding of not just the dissociated you know, what is the problem, but how can we really understand the problem to solve it better? And then they also come back in the fall and finish it up. So those are, you know, just a survey of all of our different opportunities, and many of those are only just our engineering ones. We also have so many more. So
yeah, I would strongly encourage it, and with the way the curriculum is developed, we strongly believe that engineering classes can be taken while studying abroad. There are just an incredible array of and believe it or not, the first law of thermodynamics works here in the United States as well as in Australia or in Spain or Germany. So all of those fundamentals of engineering can be taught anywhere in the world. We really encourage our students to take advantage of that. The senior design clinic projects are just extraordinary because the students are interfacing with groups in those in country. And then, of course, you know, the whole language barrier, the language immersion is just a really powerful component of that. And Brittany also mentioned senior design. And let me also just say that we're coming near a close of our webinar tonight. And so if there are any final questions, please feel free to submit those. We'll try to get them answered. Like I said, no question will go unanswered. There'll be follow-ups from the team here at St. Thomas to make sure that we clearly answer those questions. But I think one of the more unique aspects of St. Thomas is our engineering senior design clinic. And Brittany mentioned it in terms of our building in through our Global Summers program, building in study abroad in senior design. But we also are very proud of the senior design clinic, the more traditional model that happens here. It's a 2-semester sequence. And if I were to describe it in a nutshell, basically your first day of your senior year, you are given an entire portfolio of perhaps 40 projects, short summaries of projects with local industry or local non-government organizations. You are given just a brief description of what there needs to be accomplished and the contact information. The faculty, since they know all of the students, assemble the teams in a way that balances out skills and attributes of our students. So they build the teams of 4, sometimes 5 students. They give them the contact information. They say, go. And basically the students are responsible for basically setting up the entire tone of the project, understanding the scope, defining the problem, meeting with their clients, if you will, out in industry, and then through the course of the 2 semesters actually come back with a completed prototype of the product that will solve the problem for their industry partner. And it's just an exceptional experience. There's multiple meetings with your company partners. There's stage gate review design processes where the companies come in, review what the students are doing, and then each few months that thorough review it happens again and again, and the students really come out with an extraordinary experience working with companies. There are some other aspects to that as well. There's non-government organizations. So for example, this past year, we just completed a senior design clinic project with the Minnesota State Services for the Blind, where the students actually created a tactile diagram scanner, which would be able to reproduce original images of tactile diagrams that belong to the Minnesota State Services for the Blind library. So we're able to actually reproduce these original illustrations using the scanning equipment that our students at St. Thomas developed. So Travis, it sounds like you also would like to add on to that in terms of the clinic experience and maybe some of the other faculty, or maybe even Aaron's heard from the amazing stories of what's happening to the seniors above him.
Yeah, I just wanted to add one thing about our senior design program that I had not seen before coming here, and I think part of that came from, at least what I'm going to mention about, came from trying to add civil in. Is our senior design program is not specific to discipline, which is pretty rare as far as I know. So what I mean by that is you could be working as a mechanical engineer alongside an electrical and a civil and a computer. It's depending on what the project needs, and I think that's very reflective of what the engineering challenges that we're going to meet, or that the students are going to meet once they graduate. I think it's a lot more reflective of that, which is as opposed to being 4 civil engineers that never have to talk to anybody else. And I think one of the bridges that one of the gaps that we bridged just recently was integrating the civil and the ME, EE, CPE disciplines together into having one major, one program where you can go anywhere within that program. I think that's a big highlight for us.
Any other panelists, something to add? Okay. Yeah, no, I as my job as dean, I travel all over the country and visit probably 10 universities per year. And part of the question is, how are you doing senior design clinic? And I will say that this is really a flagship operation here at the University. It's truly unique. Industry loves it. They love our approachability and our connectedness and the ability to work on real problems that are important to them and without fear of losing intellectual property and all those things. We have a truly unique program that I would say is really a feature of what the St. Thomas experience. And as a capstone, we think about you have your great education with the faculty that you've seen here, great education and shared experiences with fellow students like Aaron. You have your internships in the summers. You might have study abroad experience. And then so with internships with this company or that company, and then on top of that, you have this capstone experience built into the program where you can talk in detail about taking something from virtually an idea all the way to fruition in terms of development of those prototypes and the delivery of them with customers being satisfied. And it's a great story to tell when you're telling all your stories for your first job, coming out of St. Thomas. You can talk about your great broad education in humanities and liberal arts. You can talk about your study abroad experience. You can talk about your multiple internships. You can talk about the hands-on skills that you've developed, whether it's machining or Arduino programming or whatever it happens to be. And then you can also tell this great story about your senior design clinic project which really is, the manifestation of everything that we do. It basically builds it all in, and customers are satisfied, and you can tell that story, which is a really important part about the experience here at St. Thomas. So with that, we're coming to a close here with our time. Again, what I would like to do is remind you that we can keep the questions coming in. There are a number of programs that are going to be happening throughout the week. As you can see on Wednesday, and Friday, there are other open webinar opportunities. What the Friday is, Ask Anything. I can't see it because it's kind of blocked by my screen here, but so there's abundant opportunities to ask more questions. I will say that everybody on this panel would be available to answer your questions directly. I should also convey to you that we at the School of Engineering are completely open to a one-on-one virtual meeting with any of our students if they have more questions or more details that they would like to, maybe some unique aspects of that weren't able to answer in the general questions that we covered tonight. But if you go online, there are multiple ways of reaching out in terms of connecting with that virtual advising or virtual tour experience. Maybe you want to know more about the labs, or you want to know more about this detail of double majoring in German, or you want to know more about this or that. We'd be happy to sit down with you in a Zoom type or environment to do a one-on-one conversation with you about your experience here at St. Thomas. We are available for you. I know this is a big decision for many of you, but I will say that we will virtually convey the kinds of one-on-one personal experience that is going to be a part of your student's life here at St. Thomas. And again, it starts even with a virtual visit session. And so whether you're on the engineering website or you're on the admissions website, just go there and click on virtual visit, set it up, and whether it's electrical or civil or mechanical or computer, or you maybe like to talk to a student, let us know. We'd be happy to get back with you. So with that, am I missing anything in our close up here? And again, so let me thank you for your time. Let me thank the panelists for their time and their contributions. I hope that everyone is doing as well as can be in these times. We're hopeful for you, and we are very hopeful for a great start to our fall, and we're looking forward to seeing you here face to face. So thank you and good night.